So you said you need help with recursive binary tree traversals, and you want to learn about in-order traversal. So what confuses you? So you get that the function calls itself, but you don't understand how the final result is stored and how the function traverses the nodes in the right order. We know we keep information through the stack. So the stack allows us to keep track of where we are and where we want to go. As every function is called, the stack builds up. So let's imagine we have a binary tree. So in order traversal, we expect D to be the first node traversed, then B, then E, then A, C, and finally F. We can do this by understanding that binary trees are inherently recursive. So as you can see, any node can be interpreted as the root. This could be the root, but so could this and this. Even the leaf nodes can be interpreted as roots as they both point to null. Or in Python, in this case, it would be none. We have first in order A. All right, once we call in order A, then we check if the node is null. The node is not null, so I mean none. The node is not none, meaning that it points to A, the A node. Now, the next thing we will do, we will call this function in order left, and therefore we call in order B now. I'm going to call in order B. And then once again, we have to go back. In order B, is it null? No. Then we go left again. So then we do in order D. So that will be our next thing that is called. Now, in order D, it's not none, no. Then we will go left. We are currently at a none. So the none, and we stop immediately. It's done. So now this is, we go to B. D is the first thing that's done here. So D will be printed first. And then after that, B is finished. So B will be next. And then we have E. And then the same thing happens here. We go back to A. So then A is printed. So far, if I write it in the text box, we have gone through B is printed, and then B, and then E, and then A. Now what happens is that we're back to the function where A is called. And what happens now is that A dot right, the node of A right is called. So we're at C now. What happens now is that C has no left node. So when the left node is called, it returns none, nothing. So then we go to this print statement for C. So C is printed. Then we go C to right here. And then C of right. So FS2 points to nothing. So then F goes through left, nothing, and then so then we print F, and then the right of F is also nothing. It's null. So that function ends there. And so as you can see, we have D, B, E, A, C, F. And this is what's printed from that. Now, essentially, what I want to say now is that notice how each recursive call handles only one thing at a time. It processes the left subtree first, then the current node. The left subtree is processed first, then the current node is processed after all of the calls are finished with this. The left is processed, and then you process the right node. Okay, so the knowledge of what's next comes from the call stack. Every time a function is called recursively, the call is paused until the recursive call is returned. The result can be either built by printing as we go. So that's what we did. Or we can pass it along a list by appending the end of the list. So we could have also just built a list from this, but we instead printed it.